Hello there, my name is Bradley Steinfeld, and this is lab number 1, going over the Hadoop Distributed File System, or HDFS. So I'm going to do this in all of the following labs from our VMware image, so it should look exactly the same. If you're using the cloud image, it should be similar, and we've noted each of the differences within the lab documentation itself, if there are any. Okay, so first of all, what we're going to want to do is open the terminal and start up our Big Insights installation. So in order to do that, just double click on the terminal icon on the desktop. It's the easiest way. And we'll simply give the command startall.sh. This is going to run and start all the different components needed for pretty much all of the labs. So let's wait until this gets started and come back after. Our startall.sh script is finished running, and you'll notice, if everything worked, that under the succeeded components section, Hadoop, Derby, so on and so forth, up to console is listed, and the failed components section should be empty. If you have something in the failed components section, then you have a bug or an error or something, so you'll need to debug. Anyways, moving forward, what we're going to want to do is we're going to want to talk with our Hadoop distributed file system. Now we're using a single standalone image, so all of the files are going to be on this one machine or this one VMware image. Normally you'll have many machines set up in this Hadoop cluster, and the whole point of HDFS is to distribute our files along each of those machines, or each of those machines you've selected to have files on. However, this is just a simulated version of that, but it works all the same. Let's clear our screen and let's start actually issuing Hadoop distributed file system commands. In order to do that, you just use the Hadoop fs command. And then to actually pass the specific command to the Hadoop file system, you do space dash followed by the command. So normally, in order to list a directory in Unix, we'll use the ls command. In HDFS it's the same, except you use Hadoop fs dash ls followed by the directory. So if we put /, it should list our root directory on HDFS. Note, this is different that if I do a normal ls /, it'll list the actual normal Linux file system. So these are two different file systems. I can also specify another directory by doing Hadoop fs -ls user root. And this shows us everything within our user root directory. Another thing to note is that our default home directory for our root user and the one that's used on this VMware image is /home /root. Whereas in HDFS it's /user /root. So just note that with HDFS, user stores all of the home directories, and on the normal Linux file system it's /home. So in order to make a directory, it works the same as Linux. Hadoop fs make dir. Let's make a directory called test. When I don't specify the absolute directory path, the default is for the file or directory to go to my home directory, so /user /root. So if I issue another ls command, you'll notice that nothing is shown in the root directory. But if I do user root, we'll see this test file, or test folder rather, that I just created. Now another way of doing something similar would be issuing a make dir command with an absolute directory path and create a folder called test2. And now we'll see both the test and test2 directories in our home directory. Also, we can use the Hadoop file system similarly that we'll use any other Linux command, so we can pipe commands onto the end. For example, if we wanted to see only the directories within user root that have test in the name, we could do Hadoop fs-ls user root. So this is the normal command to list all of the folders and files within our user root directory, and we'll pipe grep test to the end of it, which should grab only the lines that have test in them. And you'll see that's exactly what it does. Now, in order to move files between our normal Linux file system and our distributed file system, we use the put and the get commands. Specifically, the put command takes from our normal Linux file system and puts the file to our distributed file system, while the get command gets a file from our distributed file system and places it on our normal Linux file system. So let's put a file from our local Linux file system onto HDFS. Again, we do Hadoop FS, specify the put command, and let's just put on a README file that's included. So Big Data University /README. So that's the from file, and now we want to specify where we want to put it to. And let's just write README. And what that's going to do, as mentioned before, is just going to create a file called README in our user root's home directory because we didn't specify an absolute path. And it should just contain all the data within /Big Data University /README. I issue the command, and now let's test that it worked by doing an ls on our user root directory to see if the file exists. We'll see it does exist. And now to view the contents of the file we just created, let's issue a cat command. So Hadoop fs-cat user root readme, or just readme itself would work. We'll see it shows I am a readme file. Also, we can do something like this, diff, throw in Hadoop fs cat readme, and compare it to our normal readme. So this is just a way of pretty much saying, is there any difference between these two files? So diff is just a Linux command which tells you what's different between two files. The reason why there's the less than sign in the brackets is just because it's turning the Hadoop fs command into a temporary file of sorts. Since nothing was returned, we can see that the two files are indeed exactly the same. Another way would be to actually run a cat command on the readme file, and you'll know that they both say I am a readme file. Thus, they're both exactly the same. Another command to keep track of would be the lsr command. So normally, if I were to run an ls command on the user directory, we'll just see only the directories and files within that directory, not the subfolders. However, if I issue an lsr, it's a recursive listing. Therefore, we can see that everything, even files and folders within subdirectories for our /user directory, is listed if we use -lsr. Also, if we want to know how big and how much space files and folders are taking up, we can use the -du commands. For example, if we want to know how big the readme file is, we can do Hadoop fs-du readme. And you can see it spits out that it found one item that is size 18, so that's actually 18 bytes. We can also do the same thing for a directory. Hadoop fs-du user root. And it'll show us that indeed we have 4 items and all of the files in here are listed. However, if we want to actually get the total file size of a folder, we need to use the dus command. So that's a recursive du of sorts. So Hadoop fs-dus user root, and you'll see it lists 18, which is the total size of the folder. This makes sense considering there is only one file in that directory. Now, there's a lot of different commands which you can use with the Hadoop file system. Many of them are very similar to their Linux counterparts. For instance, there's a du command in Linux which works very similarly to the du command within the Hadoop file system. And in order to get more information, you can either go on the internet or actually just type Hadoop fs-help, and you should get information about all different types of commands. You can see cat here, get here, so on and so forth. If you want information on a specific command, you can type Hadoop fs-help followed by the command, for instance, dus. Now just note here that the command does not have the dash in front of it, only when you want it under help. So here, if I do Hadoop fs-help dus, it pretty much tells us what the dus command does. Congratulations, you're done lab number 1.